This is question 3. A Pelton wheel system with 2 jets receive water supply from a tank. The delivery pipe length is 2 kilometers. The tank located 380 meters above the nozzle. Turbine rotate at 500 RPM and produce 5 megawatts. Loss head of flow in the pipe due to friction is 8% from the turbine head. Pipe friction coefficient is 0.006, CV is 0.95, and phi is equal 0.48. Nozzle efficiency is 0.9, and overall efficiency is 88%. Okay, so the nozzle efficiency here means, okay, we just change a little bit in terms, okay, but I think you know. So efficiency mean power out divided by power in. So if efficiency is 100%, mean the power out is actually equal to the input one. So the nozzle efficiency means the minor loss at the nozzle. So another words to reflect or to describe about minor loss. So means that this efficiency of nozzle is 0.9, means nozzle output is actually 0.9 from the input of the nozzle. Okay, that's I hope you could understand this one. And the question is about calculate the diameter, the pipe diameter, and the diameter of Pelton wheel. So we go for the pipe diameter. So here first, because the idea of pipe diameter here is maybe relate to this one, the delivery pipe. So let's say we start from the Bernoulli equation. So we have point number 1 here and point number 2 here. So and then we could have Bernoulli equation. Okay, so and then the major loss is 8%. So 8% from the 380 is 30.4 meters. So and then here, because we already know the value of major loss, might be we just substitute the value of 30.4 here. So and then after we produce this one, we could get that the velocity at the nozzle here, the output, main point number 2 here is 82.81 meter per second. Okay, so and then we know that the nozzle efficiency is 0.9. So mean the minor loss at nozzle efficiency here is actually 0.9. So and then we need to multiply it with the minor loss. So 0.9 from 82.81 is 74.53 meter per second. So mean, you know, when it's flow through a nozzle, so the velocity will reduce a little bit. So it's reduced from 82.82 meter per second to 74.53 meter per second. So and then when it's travel from point 2 to point 3, so it will slowing down. So the coefficient is 0.95. So mean again we need to multiply this coefficient into the V3. So now V3 is 74.53. So we multiply with the coefficient 0.95. So we get 70.80 meter per second. So 70.8 meter per second is actually the velocity that hit the bucket of the Pelton wheel. So and then if we want to calculate the effective head, so we could calculate by using the velocity that hit the bucket. So we use this equation. So I already explained you about this, and we get that 255.47 meters is the effective head at point number 3. You could see this here. So you put 380, the elevation of the water source. However, the energy that hit the bucket is actually 255.47 meter only. So I hope you could get either from this calculation. So and then we could calculate the velocity of wheel because we know the phi here. So we multiply 0.48 with 70.8, we get 33.98 meter per second. So this is the value of U. So and then we could calculate the flow rate by using this equation. So, and then we put the effective head here 25 because the 255 meter is actually the input of the Pelton wheel. So we could calculate the value of Q is 2.27 meter cube per second. Then, so we know that we want to calculate the diameter. So maybe we could calculate using the major loss here. So we know it is equal to 30.4 meters. So this is the equation of major loss. And then because it is difficult for us to determine the velocity inside this pipe. So what we do is we replace the term of velocity into the terms of flow rate. So you need to substitute with this term. So, and then in previous notes, I already show you how to solve this. So you just substitute with the value. So we know the Q here. So we know the F from the question. So we could calculate the value of D. The diameter of delivery pipe is 0.70 meters. Then the diameter of Pelton wheel, it's quite simple here. We know the value of U is equal to 33.98 meters. So we use this equation, then we could finally determine the diameter of Pelton wheel is equal to 1.298 meters.